for this next stage, tomorrow's part of the mission, that were ever problematic and is something that you're really looking forward to, I guess, a point getting past beyond the actual birthing itself?
Certainly. I've been working with NASA on this mission specifically for a little over 5 years now. We've been simulating for almost 3 years in various stages, but really the main thrust of our simulations have been over the past year and a half. We've conducted almost 20 joint simulations with NASA and over 40 simulations internally here to SpaceX among the 4 shifts of operators we have working. So we've been working it very hard. We fly by the mantra of train like you fly and then fly like you train. And so far the mission has been proceeding just like a regular simulation, so we're very pleased with that. Tomorrow, as Holly said, it is a test flight, so I don't want to jinx myself and say what I can expect and then see something different. But right now the mission is looking just like our simulation, so we're fortunate there, and I'm not expecting anything that we haven't seen in a simulation.
Were there anything in the simulation that that was sort of that hump that you had to get past, or that hump that caused any issues that you're going to take a breath once it's over tomorrow?
We use the simulations, and as I said, we've been simulating for a number of years. We use them to iron out work on the hardware as well as in the operation. So it's one of those nice things about SpaceX because of our development process, and we're all under one roof here at Hawthorne. When we find something in a simulation, we'd go back to the hardware people and talk to them about it and be able to iterate back and forth. So I'm not expecting anything that the teams at least aren't prepared for. We have a very cracked team. There's always a chance of something that we haven't simulated coming up, but we also have hardware in the loop here in Hawthorne that we can run against before we do anything on the spacecraft. So again, I'm very confident, and our simulation supervisors have been, I think they've enjoyed torturing us with very unique scenarios, so we're looking forward to birthing day tomorrow.
Thank you.
Okay. Let's go to Marcia Dunn, Associated Press.
Yes, hi, good morning. I have a question for John over at SpaceX. What was the atmosphere, the mood like when you completed the operation this morning with such finesse? And I'm wondering, what kind of a mood does that put you in for tomorrow? Are most of the nerves gone now that you did so well?
It definitely does help with the confidence. Again, achieving the C2 mission objectives, the original C2 mission objectives today, is a big confidence boost. Everyone's very excited. We want to make sure everyone got to bed, so they're well rested for tomorrow. But it's exciting to be, an American and part of the of putting American spacecraft into orbit, and we're very proud right now.
Thank you very much.
All right. Clara with Space.com.
Yeah, hi. My question is for Holly, and I'm wondering, when was the decision to give the official go-ahead for birthing made, and what was the process of decision-making there? Was it just a straightforward thing?
Let's see. So it's actually a series of decisions. So when we talk about the fly under today, we did sort of step one in that process. So we did a go, sort of an official poll, both at the control center in Hawthorne and then the one here in Houston, in order to bring the Dragon up to that 2.5 kilometers below the space station for the fly under. As Dragon flies around the space station over about the next 20 to 22 hours, there's a series of those decision points, and at each one of those you're checking really the health of both spacecrafts and make sure you're still in what you expected pre-flight in terms of your performance and your systems. And so you do that overnight, and then you'll start into your rendezvous sequence. I think of it, it basically starts at the point where we were. We call it the HA2, the height adjust 2 burn. That's the burn where we started the fly under the day. Instead of going under at 2.5 will continue on up towards the space station, and you can see each in the graphic that they just put up for me. You can see each of the kind of brown, maybe red-colored dots is another height adjust maneuver. So again, you're turning on the Dragon engines. The team in Hawthorne is and moving the Dragon closer to the space station. And each one of those points again has a pole, has a go in our nomenclature, and you're doing that at 2.5, you're doing that at 1.4. We do that again several times after the Dragon is again on the R bar, which is kind of that space below the space station if you drew that direct line from the space station down to the center of the Earth. And so the final go for berthing is actually very close to the space station, so 10 meters. We call that the capture point. And so after you've crossed through all the gates leading up to that point with an increasing number of systems that you need to be working correctly, then you give that final go. Again, that's a joint poll between John's team and my team here in Houston. And then after that, you really turn it over to the crew. You tell them your go for capture. They take both spacecrafts into a free drift, again, so that the thrusters do not fire on either spacecraft, and reach out and capture Dragon with the arm. So when we talk about there having been a go for berthing, it's really, again, a series of activities, the last one being right when Dragon is very close to the space station. And that'll occur about 7 a.m. Central Time tomorrow. Again, roughly, because we've got a lot of data to look at and activities to perform, but that's the rough time where that last go for berthing will occur.
Thank you.
Okay. Brian Berger of Space News. Brian, are you there? Okay. Let's skip to Brendan McGeary with Bloomberg.
Thanks, guys. Just, I guess, 3 parts here, hopefully pretty brief, though. Can you just summarize in brief what happened this morning? Clearly the fly under is sort of a milestone, but, they mentioned the strobe light there. Just a few more just highlights on what exactly you guys accomplished this morning. 2, where things, are going, I guess, throughout the day. You mentioned sounds like the race tack, the circling is now what's underway. And then 3, just confirm for me the scheduled berthing time for tomorrow.
Okay, well, let's see. The first part, I actually was going to ask John if he wanted, from his perspective, to give you the highlights of the fly under, since it was his spacecraft we were seeing for the first time.
Certainly. So right before the flyby, yesterday and the day before, we performed some spacecraft checkouts, which included an abort demonstration, and then our GPS demonstration of Dragon navigating off GPS by itself, and then a free drift demonstration. And free drift is where we shut down all the thrusters, and we do that at that 10-meter point that Holly just mentioned prior to being grappled by the arm. So we demonstrated all those, and we're ready for flyby today. For today, our major mission objectives were to prove first our COTS UHF communications unit, also known as Cuckoo, was able to close a link out to Dragon. Cuckoo allows us to communicate between ISS and Dragon at very close ranges. We're expecting roughly between 23 and 28 kilometers. We were very fortunate today. We exceeded those going, I'd say, in excess of 90 kilometers. So again, very fortunate. When you asked what were one of those points in the mission I'm kind of holding on to, it was that, and that was a great thing for us. So our Cuckoo unit allows the crew to command Dragon, and we proved that link works, and it also allows Dragon to know exactly where ISS is by using ISS's GPS state. So as we came in, we performed the height adjust and co-elliptic 2 burns, and we flew understation, performed some Cuckoo operations, and then once we confirmed GPS was working, the crew sent the crew from the crew command panel, which is a panel connected to Cuckoo, the strobe on command. And that was really to test that the crew can send a command to Dragon, and something that was benign. And we saw that the strobes were indeed on. And then we continued operations, and then the crew, through the same panel, selected the strobes off. So we have proven that both Dragon can already navigate within close proximity of station, and that the crew can command Dragon. So 2 very important mission points for today.
Let's see, so I'll pick up with the rest of your question and add just a few points. So on the space station side, in order to do the communication with Dragon, the UHF communication, we put the space station in a very specific attitude, which requires us to make sure our solar arrays are configured properly. So the type of things we do for other visiting vehicles, we also perform for Dragon. And there's a box on the space station, the Cuckoo box, the SpaceX